Light propagates in the form of small bundles of energy called quanta or photons. The energy of each photon is h nu, where nu is the frequency of light and h is the Planck's constant. The value of h is 6.62 into 10 raised to the power minus 34 joule second. If the electron absorbs the energy from photon more than the energy needed to escape out from the metal surface, that is phi 0, then the electron is emitted with maximum kinetic energy Kmax, which is equal to h nu minus phi 0. This equation is known as Einstein's photoelectric equation. Important points. For the emission of electron from metal surface, h nu greater than phi 0. This shows that greater the work function phi 0, greater the threshold frequency needed to emit the electron. The more the number of photons available, the more the number of electrons absorbs energy from the photons, and therefore greater is the number of electrons emitted from the metal surface. We know that Kmax equals EV0, and Kmax is equal to h nu minus phi 0. So, h nu minus phi 0 is equal to EV0. EVO is equal to h by E into nu minus phi 0 by E. If we plot a graph between nu and V0, taking nu on x-axis and Kmax on y-axis, the graph is a straight line, since equations is of the form y, which equals mx plus c. The slope of the line m is equal to h upon E, which is a universal constant. Example: if light of wavelength 4000 to 950 angstrom is viewed as a continuous flow of photons, what is the energy of each photon in EV? Given Planck's constant h as 6.6 into 10 raised to the power minus 34 joule second. Solution: the energy of photon can be found by E as h nu, E equals hc by lambda, name it as equation 1. C is the speed of light, which is 3 into 10 raised to the power 8 meter per second. From equation 1, E equals 6.6 into 10 raised to the power minus 34 into 3 into 10 raised to the power 8 by 4950 into 10 raised to the power minus 10 joule. After solving, we get E as 4 into 10 raised to the power minus 19 joule. It can be expressed in EV, E as 4 into 10 raised to the power minus 19 by 1.6 into 10 raised to the power minus 19 EV. E is equal to 2.5 EV. Assessment. Before proceeding further, let us know particle nature of light, the photon. The photoelectric effect supports the Einstein's quantum theory of light, which states that the light in interaction with matter behaves like bundles of energy, each bundle being called a photon. The photon picture of light can be summarized as: when radiation interacts with matter, it behaves as if it is made up of particles called the photons. The energy of each photon of frequency nu and wavelength lambda is E as h nu, which is equal to hc by lambda. The momentum of a photon p is equal to h nu by c, which equals h by lambda, where c is the speed of light. All photons of a given frequency have the same energy E, which is equal to h nu. The photons are electrically neutral, so they are not deflected by electric and magnetic fields. In photon-electron interaction, the total energy and total momentum are conserved. However, the number of photons may not be conserved in a collision because photons may be absorbed and new photons of different energies may be created, so that total energy may remain constant, that is h nu, which equals h nu 1 plus h nu 2, wave nature of matter. In 1924, Louis de Broglie proposed that material particles in motion behave as waves, and the wavelength associated with the material particles is given by lambda is equal to h by p, which equals h by mv, where p is equal to mv is the linear momentum of the moving particle. This is called de Broglie hypothesis. The momentum of the photon is p is equal to h by